Okay, if you're watching this video and you've not seen part A, can you please go back and just watch part A, substitution. Okay, in this video we're going to be dealing with part B, equating coefficients. Alright, so I'm just going to run through just in case you've maybe had a bit of a gap between part A and part B. So we started off rewriting it out like this. Okay, basically saying that what we're doing is reversing the process of adding algebraic fractions. Okay, we've been given the answer, we want to find the question. This process is splitting things up into partial fractions. Okay, then what we do is we multiply up the denominator. Okay, so we multiplied up this denominator here, and we were then able to cancel some of it out. Okay, so this is a very important step. And it's exactly the same steps as what we've done in substitution. Once we've done that, they're kind of simplified to give this. Okay, so we had 6x minus 2 equals this. Okay, and what we're going to do is we're going to pick up from this point here for part B, equating coefficients. Okay, so there it is. And we are on part B, and we are equating coefficients. So I think at first glance this method definitely seems a lot more difficult, but I want you to stick with it. I want you to practice both, because like I said in the previous video, knowing both of them really well kind of helps you out, and you get used to, if you practice enough, you get used to which method to use for which question. Okay, so for equating coefficients, what I'm going to do is I'm going to expand the brackets. So I'm going to have ax plus a times x plus a, plus bx, b times x minus 3b. Okay? And then what I'm going to do is I'm actually going to collect, or I'm going to kind of like collect together the coefficients of x. So I've got ax plus bx, and then I've got a minus 3b. And that's still equal to, or still equivalent to 6x minus 2. So what I've done is I've put all the terms of the x's kind of collected like terms, and all the terms that are just constants together. Okay, and I'm going to write this out again just to try and make it a little bit more clear. I've got a plus b amount of x's, and I've got a minus 3b amount of constants. Okay, so you can see here that this value here is equivalent to the number of x's I have. So this coefficient of a plus b has to equal 6. Okay, and that's an equation that we can actually form. A plus b has to equal 6. And then we've got another equation that we can form, because we have a minus 3b, well, that has to equal the constant term here, which is negative 2. Okay, so those two things that have been highlighted, they're equivalent, they're the same. So we've got a minus 3b equals negative 2. Well, what we have there is a set of simultaneous equations, which I'm sure you'll all be really happy to have, in which you need to solve and find out the values of a and b. You would do this in your calculator. That is the way you would do it, no other way. I don't think I'm even going to mess around with showing you a method. I want you to learn and know how to put this in your calculator to find the values of a and b. If you don't know how to do that, I can maybe put together a video in order to show you. But essentially, you should work out that a is 4 and b is 2. Which is exactly what we found in the previous video for substitution. Okay, so just to go through it again, this is the same step we got to in substitution. So I'm hoping that that is okay. Then what we've done is we've expanded it and we've collected like terms. We've got all the x terms together, all the constant terms together. Then what we've done is we've equated the coefficients. So here is the coefficient of x, and we've put that a plus b equal to 6, because the coefficients are equal. Then we've got the constant term equal to the constant term here. We formed simultaneous equations, which we then solved on our calculator to get a is 4 and b is 2.